Well, hello everybody. I'm Jackie Jones from HGN. Welcome to our Building Sense session on solar PV. I'll waffle on for a bit while other people join us. So welcome, and a particular welcome to anyone who's joining us here for the first time. We're going to keep things fairly brief as it's still a lovely evening out there, which reminds me, it would be great if you could put into the chat any preferences you've got about timing of these events online. Whether this is a good time slot for you, but also whether you would prefer face-to-face meetings. So it would be very useful. We've got lots of planning to do, and your input would be great. Just a reminder, if you missed it, that the session's being recorded. The recording will be made available afterwards, and we'd love to get your questions into the chat to deal with once Gordon has finished his talk. Well, we're still joining people? I think so. Solar PV. One day, I reckon it's going to seem odd to have a roof that doesn't generate electricity. If you think about it, a couple of generations ago, it was pretty special to have taps inside the house, and having electricity and electric light is still a relative newcomer, isn't it? So it's just a matter of making a shift to our thinking and to our practice. I mean, why wouldn't a roof generate electricity? Think about that. Time to introduce Gordon Coppock, who's going to speak to us, Vice Chair of Herefordshire Green Network. Gordon's got a physics background. He's worked in solar as a professional and as an advocate for many years. He's going to take us through some solar basics and then explore whether this big jump in energy prices that we're experiencing is actually making the outlay that's needed for home solar look more palatable. Gordon, as I introduce you, we heard today in Rishi Sunak's spring statement that for a minimum of 5 years, solar installations are now going to have zero rated VAT rather than 5%. Same goes for heat pumps and some home retrofit measures. His speech suggested that that was going to mean a reduction in outlay for a typical solar roof of £1,000. My sums don't quite match his, but he's the one who's supposed to be better at sums. So anyway, at that point, I will hand over to Gordon. Thank you.
Thanks, Jackie. Well, yeah, economists tend to err on the optimistic side, don't they? So I agree. We'll see later about the costs of a system. So it's all good, though, if the VAT is reduced to it, and it does certainly it's consistent with the costs of other types of energy. So that's good. Yes, well, welcome this evening, and thanks for joining us. I've been working with PV systems for over 30 years now, and so I have a lot of experience to share about things that do work and don't work. And we want to try and go over this evening with particularly some of the issues that have been raised to me over the past 3 or 4 years as to why people have decided not to go ahead for PV. So I'll start sharing a screen now, and let's check that we can all see it. Okay. Thumbs up if you've got the first slide on your screen. That's good. That's good. Always good to know, because I obviously can't quite see what you see. Yes. So I'm a member of 3 community energy PV companies, and for my sins, try and deal and support energy issues on the Marches LEP, and increasingly in the Herefordshire Climate and Nature Partnership with many other colleagues from HGN and other parts of Herefordshire. So I'm now trying to go to the next slide. So a reminder again, put your questions into the chat as we go if possible, and we'll collate those. I also find it's a good thing, because I don't know about you, but things come to you as you see a slide and as you see a discussion, then it's quite useful to put the question in at that time, whereas if you wait to the end, it might all get forgotten. So one thing I try and caveat this with is that just a reminder on the general theme of building sense, before we start talking about generating energy, let's just remember that the cheapest energy is the energy you don't need to use. So the saving energy side of things is the side of things to focus on first. But this evening we are going to try and concentrate on solar PV, and then partly because this whole series is supported by Western Power and focused on the Keep Herefordshire Warm section. If I can remind you, if you do have any neighbours or friends or people nearby that you could, as a trusted person, share with them the contact details of that and some of the other things like the last session we did on low cost improvements to homes, I would remind you that that's there, and really appreciate it if we could share that information around and the contact information, because obviously with the awful increases in energy bills, even a higher percentage than our already high, about 13% fuel poor is going to increase enormously across the county. So what are we going to talk about tonight? So I'll go over first what a basic domestic PV system is. For those of you that already know that, apologies, but I just want to make sure we cover all the basics. Then a bit on the extent of solar PV and its significance in the UK. And then I'll come back to the financial case right now for where we are going and where it will be in the course of this next year with the incredible energy costs increases that we might see. Then the carbon footprint and embodied energy of PV, some other environmental and human equity issues that have come up in recent years, to be honest, since I last did a talk like this, and ending towards how long they last and can they be recycled, because they're also common questions that comes up. Okay, so is any roof suitable? In the UK, it's certainly a very, very large number, and far larger than we currently have with PV on it. So ideally, a roof of about between 25 and 45 degrees pitch, and in any direction, east, west, or south. You wouldn't put them on the north, and that's about the only place I would recommend not to put them. But apart from that, it's possible to site them in any of those places. If you have a dual pitch roof, east and west, you can have effectively two separate systems, one that benefits the early part of the day and one that benefits the second half of the day. And in some countries, it's now been changed so that they're making it a planning thing that you have to go east-west because there's too much PV being generated at the middle of the day from the south-facing roofs. And that may come in this country at some point, but it's not yet. But that's good because that means that there's an enormous amount of energy from the sun. And as Jackie said, why wouldn't we? Tonight, I'm really going to be focused on roof mounted, but if you haven't got a suitable roof, by all means, still consider it because ground mounted systems are possible, but you will need planning permission for that. For a roof mounted system, you don't need planning permission. Certainly on a system up to 4,000 watts or 3.68 watts into that, actually delivering into the grid, you don't need buildings regulation either if it's installed by an MCS or a certified contractor. So that figure I've given at the bottom of 18 square meters is using very efficient panels. And I've emphasized that because the amount of area that you need has dropped significantly. Again, pretty much since about 2015, the figure was more like 30 square meters. But now with panels that aren't a great deal more expensive because of their efficiency, they're 18 to 20 square meters is quite achievable. And that means that a smaller roof can have a larger system than they could have in the past, which is great. And this I've just done today for Herefordshire. And this is a rollout of how much energy, so each of the blue bars depicts how much energy you might generate in a month. And that's a typical average figure for it's actually at central Hereford, and a 35-degree pitch roof south facing for a 4,000 watt or 4 kilowatt system. So that's significant. As you can see, it's obviously distributed towards the sunnier months of the year, but certainly for the systems that I have here at home, we use some of that energy for charging an electric car and hot water heating at some points, and we get useful amounts in February and March, less so in January and December, but that's about the only two months of the year that we don't get significant output from it. So a typical house in the UK, excuse me a moment, we use about 4,500 units, and those units are, as you might have learned on your old bills, they're now called kilowatt hours, and that's how units are classified on your electricity and your gas bills. It's just a unit of energy. A kilowatt hour means if you had an old type 100-watt bulb on for 10 hours, you'd be using one kilowatt hour, 1 unit of electricity. Or if you had an electric bar fire on that was using 1,000 watts, and you left that on for an hour, you get a lot warmer, but you'd be using 1 unit of electricity. And a 4,000 watt PV system, as we've just seen on that graph, and I've just put a smaller version of it in this one, it will generate approximately 3,600 units per year. That's an average figure, and of course, in 2020, we saw systems generating much more than that, but in 2021, they actually generated less because we had a slightly cloudier central part of the year, June and May in particular. But on average, I've had PV systems for grid connected systems for about 17, 18 years. And I've seen a fairly consistent figure, average figure over that time. But of course, I don't want to fool you to think that you can make use of all of that energy. You can't, because it's not going to occur at the time when you want to use it in your house. So the beautiful thing about grid connected panels, though, is that that energy won't go to waste. It'll go out onto the grid. So other people nearby you, the neighbors and everybody else, or even further afield, will be able to use that energy. So it's estimated that most homes will use or be able to use 50% of the energy generation. So that'll be about 1,800 units per year. And let's see if this little animation works. This is to try and get over that point of what happens to the energy and which way does it flow and how does it all work. So on the left-hand side, we've got the energy during the day, but the house isn't using all of it. So some of it will flow to the house, for anything that's left switched on in the house, and the remainder of it will flow out to the grid, and then it will go to the next needed point along the grid. And then in terms of this case, the output from the PV system isn't quite enough to meet the demand of the house. And so it's partially met from the PV system. So you save money because you're not importing as much from your energy supplier from the grid as you would do normally. But the rest of it is seamlessly supported from the grid. You don't have to switch anything or do anything. That's just the way it works. And finally, at night or on a very dull day, that's where your electricity supply would come from. Again, you don't have to do anything. It's just that's the path that the electricity will follow. But at that time and at night, of course, you're not generating electricity. So for all of that stuff that does go out to the grid, like in the first example, you can get paid for that still. And that's something called a smart export guarantee. For the amount and how that works, I'll come back to that later when we're talking about the overall financial situation for the PV systems. Okay. So let's have a quick think about what the significance of this is for you as a generator. And this may be of interest to you, or you may just be interested in how you can benefit yourself in the house. But the blue box at the bottom shows the amount of generation just in the UK, only from residential houses, and it's very significant. It's 2,500 megawatts is a lot of energy. That's a power station at least. And when we had that power cut in the east of the country, I think that was in 2018, it was pretty significant as to what a difference the roof-mounted PV of quite some large cities and rural areas was contributing at that time. But I've also noticed with that bar that I put on, that arrow, that shows the significance of when the feed-in tariffs, the amount that you used to get paid for what was generated, stopped. And that's definitely slowed the accelerated growth of PV systems. And that's a shame because overall the costs of all the equipment has dropped by a factor of 4. And it's really just a perception of it not being a financially prudent thing to do, because it still is, particularly as the costs have dropped so much. And just to give you an idea, because I do have some people over the years that I've spoken to that would say, I can't believe that ever amount of energy would ever be generated that would move move a train out of Paddington Station. So on this day, way back in 2016, we already were generating just from solar PV in the UK more than all the power stations from coal that were still operating at that time. So it is a very significant and a very useful addition to the mix. And we do need a mix of energy sources, and PV is just one of those. So not only that we need a mix, but we also need to increase the speed and the build rate and of what we need to achieve to get anywhere near to the climate change government's council net zero pathways plan. So that yellow indicates the amount of installations that we need to get done, or the quantity of generation that needs to be done. So particularly at the present time, with everything that's going on in the world, I think we need to consider the resilience and the fact that we can generate a lot more here. So this is a reason for doing this event tonight, really, to indicate, to go through all the reasons that I've had expressed to me why people don't do it, and to discuss openly the pros and cons of it, of adding PV. So you can make a difference to the total energy generation capability of the UK just by putting PV panels on the roof. That's the point I'm trying to make. So let's go into the financials. And this is a useful, I hope, summary of where we are at the moment. So on the first column, I don't know if you can see my cursor on the screen. Can you see that? We shall see. On the first column on the left-hand side, that's present prices for electricity, about 18 pence per kilowatt hour. So this is all stuff I've already talked about. This is for a 4 kilowatt system, or 4,000 watt system. This is the amount that it would generate a year, 3,600 roughly of units of electricity. I'm assuming a self-consumption of 50%, as I've said on the other slides. And the cost of the installation we're taking is 6,000 quid. It has gone up, unfortunately. It was down to about 5,500, but due to everything else going up, the local installers have advised me that at the moment it's averaging at around 6,000. Obviously, it would depend on your particular house, your heights of roof. Mostly it's included for scaffolding to be included. So it could vary around that price, but that's just an average figure at the moment. And you can see right at the bottom, the payback time in years with the present price of electricity is roughly 14 years, which is lower than it was soon after the FITs ended. But it's still maybe too long for some people to want to consider it. So after the April price cap that we're about to experience, the predicted price of electricity is in the region of 27p per kilowatt hour, and that would bring down the payback time to 10-ish years. And the way I've calculated that at the top is simply the export income that you can generate from those smart energy guarantee export fees that I mentioned earlier. The amount of energy that you can save on your electricity bill, and joining those two together, and that gives you an annual income from your PV system. And then that's simply, I haven't done it in any more complicated ways. There are a lot more complicated ways to do this and to show this financial assessment. I try to keep it as simple as possible. And that's showing a payback time at about 10 years. And unfortunately, it looks like it's going to go up again at the next opportunity to increase the cap, which is in October. And at the moment, the predictions are that it will increase to 36p a kilowatt hour in October onwards, which is quite hard to believe. And it's even more galling because of course, the cost of renewable energy as generated by the wind turbines and all the solar installations around the country is not going up. It's simply, as you probably understand, because the electricity price is guided by the overall market prices, and gas turbine generated electricity is shooting up enormously because of the impact on gas prices worldwide. And that's why we have to then follow the same thing, which is unfortunate. And there are lots of discussions in place to see how we can change that in the future. So but I won't go into those tonight. And then finally, I was asked to include, for some people who may be interested in electric vehicles as well, the consequences of if you could use some more energy yourself and increase your self-consumption of what you generate. And if you could, let's say, increase it from 50% of what you generated up to 75%, then the payback time could drop to between 5 and 6 years for the overall system. So that's certainly getting interesting, I would have thought, for most people when we're considering between 8 years and 5 or 6 years. Okay. So on the point about the charging, I just thought I'd show you something. It's hot off the press. I've taken the pictures only this morning, especially for this presentation. So this is a device that I have fitted, which shows which basically drip feeds the car when it's plugged in with electricity, if there's any spare. And in this particular picture, it's showing that I'm generating 4.4 kilowatts. The house at this time, I think the washing machine was on, was using 3 kilowatts. Almost nothing going out to the grid. When it's that sort of figure, it's effectively nothing. And the car was using the remainder, being charged at 1.4 kilowatts. Okay, so that's I was making absolute maximum use of what I was generating at that time. And then if I wanted to generate or charge the car faster, and I didn't want to wait for when it was sunny, I think we've got a microphone on somewhere. If somebody could switch their microphone off, I'd appreciate it. Thanks very much. We've got the same sort of generation, about 4.3 kilowatt. The house was using less, 1.4 kilowatt. And then the extra, in order to put it in the car at the fastest speed that I can charge at, which is 7.3 kilowatt, had to come from the grid. And that's the way it works. And again, I don't have to do anything. I choose which of these modes I want, whether I want wait for the sun sort of mode or as fast as possible, please. I need to use the car mode. And that at least reduces my expenditure on electricity for charging the car, in this case, to about half of what it would be otherwise. Then there is a final mode on this particular device called where it's a trickle charge, constant trickle charge of about 1.4 kilowatt to the car, but it only adds more when there is spare available from the solar panel system. So that's what's happening here. The generator is generating about 4.3, the house is using 1.4, and the difference is going into the car. Now, if the house was using more, or there was no generation, then the car would just be getting 1.4 kilowatt from the grid. This is like the minimum level of charging. It's just sipping electricity at that time. So I don't use that mode very often, but it's useful if you sort of know you need to use the car, want to get some electricity into it, but would actually not too rushed in time-wise, and you want to make your maximum use of the sun where you can. Okay. And then this complicated list, I'm going to give you the link to this, so don't worry about the details of it, but this is basically a present regular update of all the people and all the energy suppliers offering the smart export tariff. And it varies a lot. As you can see, the different figures on there vary from a bit of a paltry 1.5p from the very generous EDF to 12p from Tesla, but I suspect that's linked in with a battery system deal that once you've got their battery system, you can also do this. I don't know that for sure. And the figure I used in the example for the payback calculation was around 5p. It's roughly in the middle. So there's a lot more companies offering this than there have been in the past, which is great, and you have more choice. So that's a good thing to see, and that's definitely an additional benefit, and I suspect this will increase even further as basically each unit of electricity becomes a lot more valuable. And that's the link. So the slides and the recording will be available later, so don't worry about not writing that down at the moment. So home battery storage, I'm not going to spend too much time on this tonight because there's a whole list of other issues to do with batteries that maybe we can come back to in the future. So maybe you can let us know if you'd like another discussion on batteries. It is another specialist area of mine, but I don't want to go there tonight too much, but I just thought I'd mention these few points. Typically the battery is installed inside or quite often nowadays outside as well in a waterproof enclosure, and it will feed power into your house automatically with the more complicated systems that you can get now. And it will charge up the batteries when you've got spare power, a bit like the EV example that I gave you. And it will try and supply the load if you program it that way. You can select that it only does this in the evenings, for example, or you can select that it's doing it all the time. But it's all about trying to increase your self-consumption. And it's a good idea if you've got PV, you just have more meters telling you what's going on with your electrical usage, as we've got used to having here. My wife and I, we've got lots of spare electricity, we put the washing machine on or use it basically. In terms of the economics of a battery system, it didn't make any sense at all from a payback point of view. But of course, with the changing situation landscape of the costs, it is certainly going to be more viable now. And I know there's a lot of interest in them from the installers being very busy, being asked for them right now. So generally, I've tried to look around the current costs and estimates of it's at least a 5 to 6K extra. So it's the same price again of the PV system for a basic add-on. And I bet by basic, I mean, it's not got very much capacity. So you might want, say, more than one module or more than one lump if you really wanted to do it. But there's some really good things. I mean, just in our family at the moment, we're discussing it because we have one, maybe there's an urgent medical need for having absolutely dependable power, and that's a fair enough reason for going this route, and it's a way that you can supply very dependable power. So you've got a sort of an energy backup system for your home. There are some sustainability issues with batteries, and again, I'll go into those another time. They're quite broad and big. So let us know if that's of interest. We've got enough interest in it, we can create one. Okay. So let's take a look at the embodied energy of a PV panel. I don't know if this term is familiar to you, but hopefully it's becoming more familiar, because basically everything we use and buy has embodied energy in it, and it's embodied carbon effectively, because in order to have used that energy to make it, that energy has had a carbon footprint. So PV manufacture is split into the manufacture of the cells, the little square bits that you see in a panel quite often, and then the assembly of those cells into the panel. Some manufacturers do everything, and they create the cells and make the silicon and then assemble them and sell the panel, but many don't. Many buy the already processed silicon and turn it into a panel. And that means that they don't necessarily know how that cell was made, or even care maybe. And they don't know what the carbon intensity of the energy used to make that cell in the first place. So when you're looking around for panels, it's a good idea to try and dig down a little bit deeper and find out what's going on with where the silicon has come from. There's also two different groups of the way that the silicon is made. And there was a process called the Siemens process, which is still quite commonly used, but it uses a great deal more energy in order to make the silicon. So if that energy happens to be renewable energy, it's okay, but most of the time, to be honest, it isn't. And if it's made in the country with are still using a lot of coal for the power, and that power is then used to make the silicon cells, you can see that begins to be a bit of a problem in terms of the total carbon footprint of those cells. So it's good to look for that. And in the past 10 years, the situation has improved enormously with the visibility of this, partly because certain countries, which I'll come to, have requested information on this. So let's have a quick look and see how it has improved in the manufacture of the cells. So with this reference from Luen and Pell, they've looked at all the different information available that shows the carbon reduction over time since about 1990, and they've even projected it forward, as you can see, with how they expect it will go with further improvements in the future. The rate of improvements won't be that big in comparison to how they have been, but you know, if you just compare a panel from the 1990s with one that you can make now, it's an enormous difference. It's you know, 76% lower in terms of the embodied carbon for that for most panels, and it will continue to improve. So that's good. So for a PV system, now I'm jumping from just a panel to the PV system because maybe this is more useful for you and more easy to understand. A reference system had a range of 20 to 34 grams of CO2 equivalent, that's what that little E stands for, per unit of electricity it generates. That's the way you measure the emissions from any generator. It's including a nuclear power station or a gas power station. That's the way you have to measure it. And as you probably know, our electricity in the UK has improved greatly since about 2010, when it was 500 grams of CO2e per kilowatt hour, and now it's hovering around 200 grams from what comes out of the national grid as an average figure. It's roughly at around 180 to 200 grams. You can get an app on your phone if you're so inclined, and you can see what it is from minute to minute, and then worry about whether you should plug something in or not. But I wouldn't recommend it. But it's useful to be able to see, and the national grid have opened up information so that we can all be aware of it. I mean, just as an aside, it means that things like electric vehicles are getting cleaner in terms of carbon emissions without having anything to be done to them, because they're being charged by electricity that is increasingly lower carbon. So that's like having a refit done to all the whole fleet of electric vehicles in a country without having to touch them. So that figure that was on there for 20 to 34 grams of CO2 for a PV system ranges from the deep south of England for a south-facing system to an east-west facing system in Aberdeen. So worst case in the highest part of the country. And that's allowing for a 0.5% annual degradation in the PV output. I'll just explain that a bit. Every manufacturer recommends how long or what output their panels will provide, and that's an average figure. Some panels are less than that, but that indicates over the warranty lifetime how much the power output could degrade by. I found it's generally less than that, but that's the figure that they show as a maximum. So for a PV system then, it's defined as low carbon energy because it's anything that is less than 50 grams per kilowatt hour. And that's a definition that the IPCC has agreed on for all things to do with climate change. And typically, for a PV system's embodied energy of manufacture is recovered if it's in operation as a grid-connected system for approximately 1 year. When I was working at Wind and Sun, I had a lot of people who wanted to become disconnected from the grid and be totally off grid. And it took quite a lot of explaining to them why it was that it wasn't necessarily the most sustainable route, because that electric solar array that they wanted to invest in wouldn't ever recover the energy of its manufacture, because when their battery systems were full up, there's nowhere for it to go. It would effectively turn off. So it's much better for the planet for all PV systems to be connected to the grid, because they're in use all the time then. And then even if your house isn't using it, somebody else is using that electricity. That's a pretty important point overall. Okay, so not all manufacturers are the same, and I'm not particularly recommending any in this talk, but I just want to show you some variation. So REC are a Norwegian-based manufacturer, but they used to make their panels from hydroelectric in Norway, but they couldn't continue to do that. So now they've moved to Singapore, and this is a plant in the industrial area of Singapore, but they have added many solar panels to the roof. So in terms of their overall carbon footprint of manufacture, it's pretty low. And they really try hard to publish all these things. Some manufacturers don't, and it's really hard to find out. I mean, a few years ago, I contacted one manufacturer for their sustainability statement for a large job that we were about to do in Birmingham on lots of social housing. And unbelievably, I got back from them, our sustainability statement is that we support a Formula One team. And that was it. But things have changed a lot now. And I think many manufacturers have woken up to the idea that they need to be clear with what their overall position on this is. Another group that's started up that is really focused on sustainability is Meyer Burger Panels in Germany. And I would look them up online if I were you, because I couldn't put all the information that's on their website just on this one slide. But they supply all their sites with 100% renewable electricity, which means their embodied energy, of course, is much lower for the panels. And they're really taking care about the circular economy side of things and the overall environmental footprint of the panels. And one of the reasons why it has improved is that France and one other country has implemented a system where it requires PV panels to be made available to them with their embodied energy commitments from the manufacturers. And then they particularly when they do tenders for public purchases from local authorities and things, that's driven so that they get the business rather than ones that are not giving the information out, which is a really good direction. So there is something called a carbon footprint certification, and some manufacturers will have done that, and you can obtain that. So also, I just think, considering the world where they are made and where the energy for manufacturing is likely to come from, you can look that up. It's also online, but that's another thing you can actually think about. And it's not just for the panels, the rest of the system. There are manufacturers that take great care to make sure their products for the rest of the system. Like this is a roof of a company called Schletter, also in Germany, where they've covered the roof with PV panels, and they make all the mounting gear for fitting them onto the roof properly and making sure they don't blow away. So they're a net zero manufacturing facility as well. And also SMA inverters in Germany have been net zero for the manufacturing of inverters since about 2012. So what about other concerns? And I've had these expressed to me in recent years, so I thought I'd try and cover them tonight. In 2021, there is a report called The Broad Daylight from Sheffield University, and it really focused on the situation in China for the in the Uyghur region, where at the moment 45% of the world's solar grade polysilicon is manufactured. But there were lots of doubts raised in that report, even from documents from within China itself, about the fact that slave labor is effectively being used for that production, those production facilities. So I would really look at the anti-slavery statements from any company manufacturing panels you're choosing. It's again, or another alternative is to just take care when using PV panels made in China. So that's just two areas on that. I think it's true for battery systems and other things as well. We really need to be sure that the fairness of their manufacture around the world is as good as it can be. So that's some things about the carbon footprint, some things about how they're built, but what about at the end of modules' life? That's another question I get asked. What are they? How recyclable are they? So let's think about the life. When is the end of the life? I do find a lot of people mix up the warranty with the life, and that's strange. It's an electrical product that is actually guaranteed up by warranty for 25 to 30 years. Some manufacturers have added another 5 years. It was always typically 25 years. And that's amazing. I don't know any other electrical product that's warranted for that sort of time, do you? It's crazy. But that doesn't mean to say that it's going to fail. Do you remember what I said earlier about the efficiency losses per year? So even at the worst case, they do actually lose 0.5% efficiency per year. After 20 years, it's still providing 90% of its output. And the ones charging my car, I showed you earlier, are nearly 20 years old, and I'm certainly not going to be replacing them anytime soon because they're still doing a good job on the roof, converting the sun to electricity. And even after 40 years, it's still providing 80% of its output. So obviously there are things that happen with technology, and maybe some people think, okay, I'll change them for a new one, but that's not the same as something failing, and you have to replace it, and then they have to be recycled as a result. So when people talk about these things, just bear this in mind. It's they can probably outlive a lot of us in terms of their function. And of course, that overall payback situation improves greatly the longer they are working for. But I tried to show you the minimum payback time in those financial calculations. So let's assume they do get recycled. And there is a really good recycling process for PV, particularly in Europe, and it exists elsewhere and around the world as well. It's called PV Cycle, and it's a complete drop-off and collection facility paid for by the manufacturers. Wind and Sun, again in Leominster, provide one of the local depots and drop-off points for broken and panels and whatever in this region. And there's places all around the UK for it. And overall, about 90%, 96% of the materials and minerals used to make the PV panel can be recycled. So that's a really impressive figure. And coincidentally, it's about the same figure as a lead acid battery, because nasty as they may seem in the materials used, about 95%, 96% can be recycled. So overall, I think that's a good situation to be in from a recycling point of view. And I've just put up 3 of the possible installers for all do a pretty good job. So to conclude then, what's the case for photovoltaic panels on a roof? Well, they generate a lot of electricity, which is really needed right now. And so anything we can do to contribute to that overall then generation of a distributed and more resilient energy generation system, I think that's why I'm doing this event, because I think it really needs stressing that we can contribute to it, and we can take a position on it if we can afford it. And the financial case makes much more sense again now, ironically because of the increase in costs, but there we go. The carbon footprint is low, and it's getting lower, providing they're grid connected modules. With care and selection, and I think giving a pushback to people who are trying to sell you other things that are maybe not so good from an environmental and human equity point of view, that you can still obtain a good product. They have a long warranty period and a really long working lifetime, so enjoy it. I should make maybe a caveat about the inverter. Inverter typical lifetime, that's the thing that changes the power from the panels to your 240 volts mains voltage. They typically have a life of between about 12 to 15 years. So it's a good idea to try and budget for an additional one of those. But I am actually finding the lifetime of those is stretched as well. And you can now get warranty, extended warranties for them as well, built in at the time of purchase. So that would eliminate any risk of cost there. The recycling of PV panels is set up and ready for use of all the materials. So it's a pretty good deal, I think, but I'm biased. But I would say I've got no financial link, by the way, to anything I'm saying tonight. I'm totally separate from, I get no revenue from saying any of these things. So not linked in any way. Okay, but we need many more of them, and we need a faster rate of install. So what are you waiting for? That's it. Thanks very much. And maybe we can go through. I've not been looking at the chat, so
I have Gordon.
Good.
So yeah, thanks ever so much for that. That was great. And as I always say, who wants to see a naked roof? Anyway, there we are. We've got questions falling into several categories, I think, at the moment. Shall we get you to stop sharing your screen, maybe? Mm-hmm. Unless you might want to flip back.
We can do that again if we need.
Yeah, let's see. So we've got some about cars, charging EVs, some about optimum sizing. We've got some about immersion heater devices to connect to an immersion heater for hot water. So more about batteries, a few architectural questions, if you like, and then a couple of comments about long-term performance. And I think that's more or less there.
Okay.
Yeah, great. So let's take them in that order then. We got questions right at the start of the chat. I think one from David Gillam and someone else saying, what kind of, or what size is probably what you meant, of system would you need if you're thinking really of charging an EV?
Yeah, that's a good question, Dave. I think I'd probably personally opt for a 4 kilowatt still because of the ease of installation. In terms of you don't need permission from the grid to install a 4 from the local electricity, the Western Power in our case. To go above 4 kilowatt, it's an application process, and you can do it for sure, and you may get permission to do it, but that's not. I can't say that. It depends on your exact location, because we do have a lot of constraints around this area in terms of what the grid can take. But 4 kilowatt is like a statutory figure. So 4 kilowatt is useful and considerable for charging a car. It would really depend on how quickly you wanted it charged. If you were using it every day and you wanted to be sure it had a charge in it, then the larger the system, the better. You know, up to 10 kilowatt even of PV. But if you were more chilled out with how long it would take to charge, and just want to put a bit back in it again to keep using it locally the next day, it could probably keep up with that. If you're trying to refill a, say, 150 mile range car with a 40 kilowatt hour battery every day, it certainly wouldn't do it. But if you wanted to top it up so that you could go to Hereford or nearby, it would do enough for that, if that's a helpful answer.
Thanks, Gordon. And talking of sizing, there's a recent question from Rob Polgrave saying, can you now install domestic systems larger than 4 kilowatts?
Oh, definitely, yes. But depending on the grid, Rob, and the grid constraints as well. Just before this, Jackie and I were both on a meeting with Western Power discussing this very issue about the grid constraints around the Marches area, and there are improvements afoot, and some of you may be lucky enough to be able to have to be able to install more than 4 kilowatts, but it's unlikely, I'm afraid, in Herefordshire.
Thank you. Let's hop to I've called them the architectural questions. They're about alternative forms of PV. So rather than using panels as we know them, roof integrated ones, solar tiles, and there's a question also about using transparent PV in the form of window film. We've also got a question from George, not quite sure how you like to be addressed, saying he likes the look of Meyer Burger, but isn't sure that they're available.
Well, just to comment on the last one first, nothing's available. Sadly, it's incredibly popular at the moment. So if you started to actually book an installation right now, I've been told by the installers I've listed to actually say it's going to be September, October at the very earliest. So that's a combination of product unavailability and their busyness, because as you can imagine, everybody's thinking about, oh, maybe I'll install solar PV. So that's that point. But in terms of tiles have been in and out of the ideas range for PV for as long as I can remember. In fact, I do remember working on a roof that was made up of tiles from BP back in the early 2000s, and they were disastrous because of you can imagine a PV thing that's very small has to be connected to lots of other small things in order to make any significance of generation. So you have lots of connections and lots of wires. So the PV panel worked itself, but its connectors and everything didn't over time because you got so many of them. So, and that's unfortunately still the case with even the Tesla offering, where they had the multiple small tiles. They've had connection problems as well. So it's fine and dandy out of the box or as a new idea to try and catch attention. but unfortunately in reality it can be something that doesn't work. You see on the other side that PV manufacturers are going for larger and larger single panels. So that's, but on the plus side, the efficiency has improved enormously just in the past 5 years. They've gone from about 16% to 22, 23% efficiency, which is why we can get more energy generated in a smaller unit area of the roof. So, and in terms of architecture and how it looks, you can get black panels with black backgrounds and black frames, and they're pretty good. You can get a range of in-roof mounting ones, but you just got to be really careful with the heat for those from 2 points of view. One is a fire risk of detritus that collects underneath the panels, and if it's not cleared, the heat under the panels on a hot day is very high, and that can lead to fire issues. And the other is the hotter the panels and the lack of ventilation underneath them reduces their efficiency enormously. So you really don't want to put panels down where they don't have a certain level of ventilation, like about 50 mil underneath them, because ironically you get the best output on a cold spring or autumn day. They don't need heat, they just need light, and that's an important part of their installation. A decent installer will do that and take that into account. Did I cover those areas?
Yeah, you did. You've not mentioned the window film. I don't think that will probably take ever so long.
Yeah, I wouldn't bother with the window film, and I wouldn't bother with flexi panels unless you've got a sailing boat and you want to put them in the sails. They're quite good for that, but they're actually giving solar a bad name, because where they are being used, they're expensive. They have a very short lifetime. It seems to me 3 to 5 years they start to break, and they're not very efficient. So I'd stick with the solid rigid thingies.
Thank you. How about diverting spare power into heating water, Gordon?
Yeah, I do that currently, and it's been, I've done it for about 10 years actually, and it's been very good.
Are you up to speed on the cost of any of the devices?
Roughly £300, maybe a bit more to have it installed, but roughly they've probably gone up with everything else, so they're probably, I should say, more like 400, probably 300 to 400. And they're very good. They sip the power into the immersion as and when it's available, and that can be done with things that are so-called resistive loads, simple things like an immersion heater. The only thing I would say is that if you are considering, as we should mention in this series, an air source heat pump, an air source heat pump is a much better use of your electricity. So, for example, if you have an air source heat pump, and many of them come with a facility to connect to solar, then they can be a much better way to heat your hot water in the summer than using your immersion. Because if you think about it, with an air source heat pump, you're getting a 3 to 1 or even 4 to 1 efficiency improvement. So you'd only be using 1 kilowatt hour of your PV to heat 3 to 4 kilowatt hours of energy into your water. And if you use your immersion, 1 kilowatt hour of electricity from your PV will only put 1 kilowatt hour of energy into your tank of water. So that's not so great. And in the greater scheme of things, if we're trying to make the best use of a resource, we should use high quality electricity for what it can be done, like powering PCs so we can all chat together on Zoom, and we can't use heat for that. So it makes sense to, in the sort of quality scale of things, to use electricity for the best things it can be used for. So just bear that in mind if you're trying to sort of plot a course to an ideal thing. But if you don't have an air source heat pump and you're not intending to get one, then having an immersion heater is a really good use of making use of your generated power.
Yeah, thanks for that, Gordon. That does mean that it's a system that includes a storage tank, heat storage tank, or heat storage device of some kind.
Certainly.
I guess, yeah. We've also had some questions when back to size of either enlarging an existing system, so upgrading it essentially. A question came from Nick Sherwood on that. And then also a question about putting a solar installation on a roof that may need to be re-roofed in, the near future. What's your advice on that?
I think basically, Nick, the best way is to think of it as an additional separate system for lots of different reasons, technically and registration wise, if you're allowed to connect to the grid or not. So I went through this with to an earlier system, then I added a second system, and it was a no-brainer. I just had to forget that I had the first system and add the second system as a totally new thing. But that was at the time of feed-in tariff and trying to get it all registered, because that's not such an issue nowadays. Maybe it would be possible, but you'd probably also be convinced by the installer to replace your existing system. So be wary of that, to remove and replace, and you can do the whole one. It really depends on roof area and space and what you want to achieve. Because on the sensible point of view, you could get more from a previous area because of the efficiency improvements. So if you're short on roof area and you really want to optimize the output, you could sell your present system secondhand. I'm sure you'll get a buyer. I bought secondhand systems, by the way, in the past and fitted them. But yeah, just to balance those things.
That's all still subject to the 4 kilowatt likely, maximum imposed by Western Power, is it?
It is, yeah. All you can do on that is to get the installer to apply on your behalf and to see what your particular location allows you to do. There are little pockets where you can do a bit more, or do a lot more actually at certain places, but I can't predict that at the moment.
Yeah. And presumably, Gordon and Nick, that would also be impacted if you're already claiming fit, because it's an older installation. You might be limited there a bit.
Well, definitely, okay. You wouldn't want to dismantle an older installation that you're getting fits on, because you wouldn't get it again. So that's a key thing. Definitely wouldn't want to do that.
We've got a couple of grid or the system related questions. Mm-hmm. One's from George about how about having a battery but no PV, so that actually you can charge your battery when power is inexpensive at night and then use it when you need it during the day. And then there's a question from Vicky about fast chargers, which is, what if everybody gets fast chargers? Can WPD cope? Okay.
With the batteries, yes, in principle, you could do that. There's always an efficiency loss when you're charging batteries, and whether or not that would really be worthwhile for the expense of the equipment and the inverters to go from the battery voltage back up to mains voltage, if you wanted to do it that way, it would probably not make sense, honestly. But it's if electricity was really cheap from the grid, which it's not, then it might make more sense. But I don't think that would make sense at the moment. And the second question, sorry, could you remind me again? Gone blank.
Yeah, it's about what if we all start charging cars at once?
Oh yes. Well, yes, as WPD tried to assure us this afternoon, they do have a wonderful plan for the number of additional EVs that are coming into their areas of responsibility, which includes Herefordshire, and also the number of air source heat pumps. And as far as I know, by the way, they're both notifiable things. So in theory, when you have a EV charger installed or an air source heat pump or a ground source heat pump, it's a notifiable thing to Western Power, so they know where they are and how many they've got to look after and provide the power for. So they've provisioned for that, and there is grid for reinforcement planned in order to make sure of that. So I'm not too worried about that, to be honest with you. I think overall, the certain centres like service stations and things like that, where you've got a lot of very, very high power chargers, much higher than we would have at home, our homes. And if you've got, say, 10 rapid chargers, imagine half a megawatt of power instantaneously, and that's enormous change. That's the beauty of all this. It can balance things, and that's where we want to be. We want to have a balanced grid of generation and demand.
Yeah. Thanks, Gordon. Which is completely fast enough for anybody who is, I should say, chose to get it so that we would never really be charging the car and drawing a lot from the grid if we were generating plenty of solar. But that's missing your wonderful device. Seems to work fine.
I totally agree, and I recommended that to people who bought Zoes, for example, because I found that Renault were misappropriating their advice and saying you must have a 7 kilowatt rapid charger or fast charger, and you don't, of course. It's just a question of time, and as you say, if you have the time or you want to, you can coordinate it to charge overnight or whatever, it's absolutely fine. But they weren't giving that impression to people buying Zoes. They were saying you must have a 7 kilowatt charger, otherwise it won't be right.
Yeah. Now, I've been given a nudge. I've been given a nudge by Richard Tyler, whose question I thought we'd answered, which was, so I clearly haven't explained it well enough. What is the situation if the roof is relatively old and unlined?
No, we didn't answer that, so that's sorry about that.
No, at some point, no, I haven't read it out quite right. At some point in the next 10 to 15 years, it may need a re-roof. Is this compatible with panels? So, sorry, Richard, I'd only half gone there.
It's a pretty important question, Richard. Yes, I mean, I would normally say really try hard to get the roof done before you put the panels on. I mean, it has improved a bit with the type of mountings that can now be used, but and therefore easier to remove. But in general, you're going to have scaffolding costs and removal costs to deal with. So, by and large, which of course have always been a fixed cost, but because the cost of the PV panels and the inverters have come down, the cost of scaffolding and labour to do it is a much greater proportion than it used to be. So it's a significant cost to have the panels removed and reinstalled. Yeah, so I would strongly recommend to try and get it done beforehand. If you can, so if you don't want to because it's not that bad, and you're just thinking at some point in the future, in the lifetime of the panels, I'll need to replace it, then maybe you could think of a way of discussing it with an installer to make them more easily removable, so add a bit more cost at the time of installation to take that into account. That's one idea. Okay.
And then we're just about there, I think, apart from a question about shading and whether inverters such as solar edge inverters can help get around the issues of shading of a system.
Definitely, yeah, they're wonderful. They're basically solar edge inverters are an inverter per panel rather than having one central inverter, and they've revolutionized sites where you had intermittent shading from trees or whatever, and it means that the whole array isn't all brought down by a bit of shading, only that one particular panel, and they're great from that point of view, and their cost point isn't that much different now from a centralized inverter.
But ideally, try to avoid a shaded installation, I think. And then a question about whether you've got any experience yourself of bifacial panels, so one's way. Both sides are sensitized.
Not personally, Ant, but it is something that we'll be using on larger scale projects in the future. So that's the intention.
Yeah, that is. Panels on flat roofs. They do go fine. They just may not look quite as pretty. Any more advice on flat roofs, Gordon?
Yeah, there's various mounts for that. There's some sort of plastic things that you fill with ballast rather than metal frames, and they can be very easy to set up, very easy to have done, but you do have to take the loading of them into account for the roof, so that can be a reason why you can't use them. Other than that, they're pretty simple. And if you can't use those, then you can have a metal frame mounting structure made by, for example, that company Schletter that I told you. They do have to be angled. Angled, I would recommend for the most part, so that they're self-cleaning, as well as getting the best generation from them. Apart from that, yes, definitely. I'm looking at.
There's also a question about the roof area, though, isn't there? Because you can't have row 1 shading row 2, so they have to be far enough apart.
Yeah, that's right. There's a fixed relationship with shading, and the installer can calculate that and make sure that the row behind isn't shaded. But so it will be a slightly more expensive way of mounting, because you need additional mounting kit. But other than that, I'm looking at a project at the moment, and we will probably have to use more of a flat roof area than we had originally intended, so that's fine.
Great. And there's a question now about planning permission, but you've already actually addressed that, saying that planning permission isn't normally needed. There are sometimes some exceptions in conservation areas, aren't there? And certainly listed buildings.
Listed buildings and conservation areas, but apart from that, not. You can sometimes get around those, I've found, by putting them on east-west locations rather than locations that are really in view. Planning authorities can be more amenable to that in a conservation area, but sometimes they're a right pain. I did get one local planning person coming back to me and said, well, I've never seen a roof ever improved by a PV panel system. So that sort of nailed his opinion to the wall, didn't it? He's moved on. He's moved on now, I'm pleased to say.
And I'm not actually sure whether Herefordshire has got published guidelines on solar in conservation areas. But very often the guideline is shouldn't be seen from the shouldn't be visible from the street, but can be on the rear of buildings. So
but maybe we can take that as an action to look up, Jackie.
We can.
It's sort of linked with how to refit and refurbish listed buildings, isn't it? In fact, we were working on that one as well. Yeah.
And then there's a question about their effectiveness on walls, so in vertical sites.
Yep. Well, I'm pleased to say I'm quite proud of an installation I've done in the Antarctic, and I used vertical panels then because of getting rid of the snow as quickly as possible. It doesn't stick to vertical panels very well, and that was so it was absolutely deliberate to ensure that they were uncovered with snow. And yes, you can calculate the losses in terms of the location because they're vertical, but they'll still generate.
Yeah, and I think one of the things that is amazing is these panels, they can't stop themselves generating. Give them a whiff of light and they will generate. So for instance, I know here where we are with south facing panels that quite early in the morning, they won't be going full tilt, but this time of year by 9 in the morning, they're going to be generating 1 kilowatt. You
just got to think about giving a pleasant life for all those photons from the sun that have spent maybe 100,000 years getting out to the outer reaches of the sun, and then 8 minutes getting all the way from the sun to us so that they can hit your panel and instantly get transformed into electrons. And that's a wonderful thing to them to do early in the morning, isn't it? So
it is. They're really happy, and the ones that don't hit a PV panel, of course, are landing on plants and creating energy that way. I mean, that's where it all comes from.
At about 1% efficiency, as opposed to a PV panel of 23% efficiency. So there we go.
Yeah. Oh. Grand. There's a comment from Nick about planning his own personal experience. But are there any more questions? I think if you've got any questions now, because we're getting close to our finish time. Yeah.
Put your mic on and do it that way if you want.
Exactly. Jenny.
Yeah, it's one that I was just trying to put in the chat, actually. Thinking about the payback time on these, and also the way prices are going up. Is there any evidence on what having an already installed PV on your house does for the value of your house? I mean, I know with Faster Share, they're saying, well, that's automatically, that's £3,000 on the value of your house. So is there, if you're not going to be in the house that you've just installed PV panels on for the payback period, are you still going to make that back up by the value that it adds?
Recent information I've got, Jenny, is that it's at least the value of the installation. So it's roughly five to 7 grand for a 4 kilowatt type system. It typically adds to the value of the house, but it can be more than that. I know that's before the present energy price increases. So it's quite likely to be perceived as even more valuable in the future.
And my take on that would be, it's much less of a concern than an investment someone might make into a new bathroom or kitchen that the next people might actually just rip out. Nobody takes off the PV panels. Yeah. Sorry, you were going to say another thing, Jenny.
No, I was just thinking, because to me, it's one of those areas that probably needs to be explained as well. Gordon, that the fact that the return on your investment is so much more than the return on the investment of the outlay. And also, I suppose, yeah, that's a really good point, Jackie, because if you're going to invest in your house to get a return on that bricks and mortar, it probably is of more value than a bathroom suite in Dago pink that nobody else is going to like.
Yeah, I mean, you're right, Jenny. I mean, after that, if, for example, it could be seen that 8 years is a payback time and you keep them for 30 years, or the house has them for 30 years, then the person's living in those houses, in that house from that time on, will of course just benefit positively every year from then on. Yeah.
Thank you. Vicky has her hand up.
Hi. Yes, I'm just wondering if there's anything. We've got a 16 array panel, and these last few days, I was expecting it to have done, I don't know, over 3. Well, no, maybe not, but it's barely reached 2, and it just makes me wonder. It is an old string system. It's not the inverter for each one, and I've been questioning, should I be changing it because it isn't? But does that sound as if it's working okay, or are there things that can go? We have it cleaned regularly.
Okay, that's good. Yeah, no, if it's, I was going to mention cleaning, but I would say even that, if it's at an angle, you wouldn't need to do that typically more than, say, every 3 to 5 years, typically. Yeah, with the present sunshine and the bright skies, I would probably expect to see a good output from it. Might be something that could be checked in that case.
Okay, thanks.
Which leads us on to another question, which is, are there any maintenance costs? I mean, normally, no, not really, I think.
No, well, as I said, if it's a flat panel, then yes, you have to clean it a lot. If it's inclined, then occasional cleaning, and even window cleaners have broadened out to be able to offer to do solar systems as well. But I wouldn't get too fussy about it. Every couple of years, or as I said, 2 to 3 years is fine. In terms of maintenance, otherwise, it's please don't listen to all the scam calls that I'm sure some of you are getting, as I get many of. If the inverter fails, you'll know about it because you won't get any output. Other than that, there's not much to do.
Yeah, unless, as happened to us, a great big branch of a tree landed on one and it still kept on generating, even though it got a dirty great dent in it. So.
They're designed to take the effect of a golf ball at 50 miles an hour from 1 meter away. So that's the glass strength. That's for hailstones in Germany, apparently.
Yeah. I think that's the end of our questions. If anyone has another question, please quickly wave or put your hand up. But otherwise, I think it's time to say, this question from Nick Shaw was saying detergents, but I think you just went there, Gordon.
Well, just water. Just water.
Yeah, I think it's time to say thank you very, very much to Gordon. Thank you to all of you. And we are going to let you know about forthcoming events. We're getting quite excited. We've got some funding through the Climate and Nature Partnership to do further events for householders, but also for professionals, some training for professionals in the building trade for retrofit. So very excited about that. Do let us know what time of day suits you for these events. And also, if you've done some retrofit work and you've got a builder who you would like to be recommending, just pop us an email to HGN admin, and we'd love to get their names. I can see Jim looking at me. Jim, you're going to be getting an email about this on the professionals list. Grand. Thank you, Gordon.
If anybody wants the battery thing, just stick it in the chat or let us know by email. Then we'll think about it. But otherwise, we'll park that for a while. Okay. Yeah, thanks very much, everybody. Thanks for your questions.
Yeah, bravo. So, round of applause for Gordon, and thank you all.